Good day everyone, this is Marvin Pidakan and today I will discuss our laboratory on microcontroller, microprocessor system and design. So let's tackle about the stack by simply executing these codes and examine the SB or the stack pointer. Also, we will examine the register since we will load some hex values into the registers before we push it into the stack. So without further ado, let's begin to simulate these codes. So now, I will click the step into or the F11 to see what the first line does. So as we click the F11, so LDI R20, then comma high, then the RAM end. So what does RAM end do here? So the RAM end is represent the address of the last RAM location, and then we specify here high, so we expect it is in a value of 0x08. So as shown here in the register 20 or the R20, we have now a value of 0x08, and then the next line we will out SPH R20. So the value of R20 will be output at the SPH or the high byte of the stack pointer. So we click F11. So as you can see here, SPH has a value now of 0x08. Then the next line, we load the immediate value. We, as you can see here, we use also the RAM end, the address of the last RAM memory location, and we specify here the low. So the low byte has a value of 0x5f. So let's step into. So as you can see in the register 20, we have now a value of 0x5f. Then this value, we will output this into the SPL or the low byte of the stack pointer. Next, so here SPL has a value of 0x5f. Then this sort of lines or the instructions, LDI, meaning we will load the immediate value of in terms of hex into the respective registers R20, R21, R22, R23, R24. So just click F11. So as you can see in the register, we load R20, we load hex 20 into the register 20. So here 0x20, then 0x31 to R21, 0x42 into R22, and 0x53 into R23, then 0x64 into R24. So now we have here the push instruction. So the push instruction, it loads the value of the registers into the stack. So remember the LIFO or the last in first out. So as you can see here, I have a image here to show what the push and the pop does in our microcontroller. So when we push the registers into the stack, the first value that we push into the stack will be stored in the RAM end or the last RAM location, so here at the bottom of the stack, then the pointer will point uh, above the given value here. So let's try to step into to see what will happen. So push R20. So R20. So this is what will happen. So R20 has a value of hex 20. So we will put here hex 20, and the stack pointer will go above it. Then next, so as you can see in the stack pointer, we have 0x5e. So here we have 0x5e. So next, we push R21 into the stack. So R21 has a value of hex 31. Then the pointer goes above it. So we have here hex 31. Then the pointer will step above. Yeah. 0x85g. So 0x85g, as you can see here in the stack pointer. So now we will push R22 into the stack. So hex 42 will be stored in the 0x85 42. Then the stack pointer will be pointing upwards, as you can see here, 0x085c in the stack pointer, 0x085c. Next, we push R23 into the stack. R23 have a value of 0x53. We'll have here hex 53. Then the stack will step above. Then next we will load we will push R24 into the stack. Alright, we have here the stack pointer must be at 0x85a, and now we have here hex 64. Then the stack will be pointing at 0x858. So that's it for the first problem. So for the next problem, we are tasked to set the stack pointer at hex 90. Notice that hex 90 is a low byte location in the stack register. Then we put a different value in each of RAM locations, 90, hex 90, hex 9c, and so on and so forth. Then we will use the pop instruction to load the contents from the stack back into the registers. So here from the codes, the first line, we initialize the high byte of the stack to hex 90, but as we noticed earlier, hex 90 is a low byte location of the stack register. So if we execute this, nothing will happen to the register. So I click F11. Then as you can see, in the register 20 or the R20, nothing is loaded. Then next, when we execute the out SPH to R20, since the value from the R20 is 0, then the SPH will also be 0 here. Then next line, LDI R20 low hex 9D. So we initialize the stock location at hex 9D. So here, and we load it to register 20. So here at R20, there's a value of 0x9D. Then if we out the SPL R20, so it will output the contents from R20 to the SPL. So as you can see here, the SPL saw value of 0x9D. Then next line, LDIR 16,1. So the value here is in decimal value. So we will load the 1 into the R16. Then so here, as you can see, R16 equivalent to 0x01. So the STS instruction, it tells the CPU to store the contents from R16 into the location of hex 98. So next, LDI R16, 2. So the value is still in decimal value. So we will load this decimal value into R16 and then we will store it at hex 99. So next, LDI R16 3 will be loaded immediately into R16 and then we will store this into location hex 9A. So next, LDI R16, 4. So this decimal value, the 4, will be loaded into R16 and then using the STS instruction again, we will store the contents from R16 to hex 9B. And next is the LDI R16, 5. The 5 here will be loaded immediately to R16 and as usual, STS instruction, we will load the contents from R16 to hex 9C. And lastly, from the LDI instruction, LDI R16, 6. So this value will be loaded immediately to the R16 and STS hex 9D, R16. The contents from R16 will be stored at location hex 9D. So next, we will tackle about the pop instruction. So when we use the pop instruction, the contents from the stack will be loaded back into the register. So here, as you can see in our representation for the stack registers, at first the stack pointer is pointed or initialized at 0x009D. So if we execute this line, we will see we loaded the value from the stack into the register 20 or the R20. So here the stack pointer will point at 0x009E and this value will be loaded into the R20. So you can see in the stack pointer here 0x009E. So here, so next we pop R21. The stack pointer will be at 0x009F. So this value will be loaded to R21. Then the stack pointer will be here pointing at 0x009F. when we execute the next line, pop to R22. So 0xFF will be loaded to R22. Then the stack pointer will be pointing at 0x00A0. So you can see here. Okay, next is pop R23. So when we pop the value, so this one will be loaded into R23 0xFF, and the stack will be pointing at 0x00A1. Lastly, when we pop R24, so showing you here the SPL 0xe2, and the value of R24 is 0xFF. So this one will be loaded into the register 24. Then SPL is pointed towards the 0x00A2. So from that, we notice that when we are popping the contents from the stock, we first pop the values in the upper upper location from the stock, and then getting the next location, the data from the next locations of the stock. Opposite to the push instruction, when we push the registers, the contents from the registers into stock, it will be stored here at the bottom of the stock or anywhere you desire the location. Then when we pop this contents or data from the stock, we will remember the LIFO, the last in and first out. So the last input, the last contents that we input to the stock will be the first output when we use the pop instruction. So that's all for our laboratory, and thank you everyone.